Suppose we have two sets of units, each of which has received a different treatment. For example, they might be widgets that have been put together using different manufacturing methods. This spreadsheet shows data from an experiment to study yields from two different manufacturing methods. We want to know whether the yields of the two methods differ by more than we would expect from the random variability in the experiment. We would also like to estimate the likely yields from each method. We'll use a two-sample t-test to analyse the data. To use a t-test, we make the following assumptions. We have two independent random samples. Each sample is drawn from a normally distributed population. First, we'll load some example data. Select File, Open Example Datasets. Click the drop-down list. Here, you'll find example datasets that are suitable for specific types of analysis. Select a Guide to ANOVA and Design. Now double-click Manufacture to load this dataset. The spreadsheet has two columns of data. The method column is prefixed by an exclamation mark, which tells us that this is a factor. The column Yield is a variate. From the menu, select Stats, Statistical Tests, 1 and 2 sample t-tests. Select 2 sample. Select one variate with group factor. Double-click Yield to move this to the Data Variate field. Notice that the available data field updates to show our factor. This is because our cursor automatically moved to the group factor field after we selected the variate. Double-click Method to use this as the group factor defining the two groups. Click Run. In the output, the t-statistic is 2.95 on 14 degrees of freedom. Under the null hypothesis that there is no difference between the means, this would have a probability of 0.011. We can conclude that this is unlikely. So, there is evidence that the manufacturing methods do differ. The new manufacturing method is producing higher yields, with an average of 23, as compared to 20 for the standard method.